Good morning, everybody. Hope you guys are having a great week. Wanted to continue our graphing trig lesson. This week we're going to leave behind sine and cosine, and we're going to focus on just the parent functions for tangent, cotangent, cosecant, and secant. And then we're just going to identify all of the features of those parent functions. So let's go ahead and get started. So we're going to start with graphing the tangent of theta. So we're going to go ahead and approach this the same way we did with sine and cosine, which is going to be by starting with our angle at 0, and we're just going to calculate all of the values on the unit circle and place them onto the graph. So a couple things we have to remember is that our tangent of theta is really equal to the y value divided by the x value of the coordinate. So what I'm going to be doing is, as I go through each angle, I'm just going to divide the y by the x, right? So we're going to go ahead and start off with our angle at 0. So here's 0. The angle is going to hit the unit circle right at this point, right? And then I'm going to be made up, I'm going to have my x, and then I'm going to have my y value. So I'm only going to show this the first time, and then after this I'm just going to plug it into our formula and calculate. So I am calculating the tangent at the angle 0. So at 0, my y value is 0, and my x value is 1, right? So that's just going to give me 0. So that's perfect. So at 0, I've got the point 0. All right, the next point we're gonna hit on is, or the next point we're going to calculate is pi over 6. So I'm going to see where does my graph intersect the angle at pi over 6, and it's right here. So now my x value, my y value is going to be 1/2, and then my x value is going to be radical 3 over 2. We know the 2's cancel out, and we end up with 1 over radical 3. Now we don't need to rationalize this because we're just going to graph it, right? So we just need an approximation of this. So I'm going to do 1 divided by the square root of radical 3, and I ended up with 0.57, right? We're just rounding, just want to get an idea of where that point is. Okay, so pi over 6, we don't see it here on the graph, but pi over 6 is actually right here. This is pi over 6, and it's got a measurement of about 0.57. So this is about 0.5 right here. So 0.5 and a little bit more, right? 0.577. Okay, perfect. Let's go to the next angle. So now for my next angle, we've got radical 2 over 2 and radical 2 over 2. All right, this, hopefully you kind of calculate this quickly, because anything divided by itself is going to be 1. So at pi over 4, we've got the value of 1, right? So this is 1, and then over here we have 1.5. Okay, so we've got that one. Let's go to our next angle, which is going to be pi over 3. So at pi over 3, we've got radical 3 over 2 divided by 1/2. We know the 2's are going to cancel, so I just end up with radical 3. If I plug that into my calculator, then I'm going to get 1.73, right? Just rounding. So pi over 3 is going to be right around here, and it's 1.73. So here's 1.5, a little bit more than 1.5, like halfway between 1.5 and 2. So there's 1.73. Okay, let's go to our next one. Right, our next angle is going to be at pi over 2. Right, so pi over 2 is going to be right here. So my y value for that is going to be 1, and my x value is going to be 0. So we can never divide by 0, right? So we know this is going to be undefined, right? It's undefined. That means that we are going to get a vertical asymptote, right, on the going through the x-axis. So hopefully you guys remember what a vertical asymptote is. A vertical asymptote is a vertical line that the graph gets super close to but never touches. Right, so here's, all right, so there's my asymptote, right at pi over 2. So this is going to be kind of strange, or because what's happening is the graph is going to get super close to this, but it's never going to intersect it. It's never going to cross it. So the period of tangent is going to stop right there. So what we have to do instead is we're going to have to actually go backwards. So instead of continuing around the unit circle, we're going to have to start from 0, and we're going to have to go back, right? We're going to have to plug in negative pi over 6. And then negative pi over 4, and then negative pi over 3. And then let's plug in negative pi over 2 as well. All right, so I'm going to go backwards on the unit circle. So that means I'm going to do the same thing. Whoops, sorry about that. Do the same thing over here. So we're going to go backwards. So if I go backwards, now I end up here. So we're going to do the exact same thing. So I have negative 1/2 is my y value, and then radical 3 over 2 is my x value. 2's of course cancel out, and I end up with negative 1 over radical 3, which we already calculated that before, right? That's like 0.57, so it's going to be negative 0.57. So at negative pi over 6, we go negative 0.5 and just a little bit more. Perfect. Let's go to the next angle, which would be negative pi over 4. So at negative pi over 4, this one we know is going to give me negative 1, right? It's the same value divided by itself. So at negative pi over 4, we go down exactly negative 1. And then the next one we have is going to be the negative pi over 3. So negative pi over 3 is going to be negative radical 3 over 2 divided by 1/2. Sorry if it's a little bit messy. The 2's are going to cancel, of course, and then we're going to end up with negative radical 3, which we just figured out a second ago was 1.73. By this time it's negative, right? Negative 1.73. All right, so at negative pi over 3, we go down negative 1, and then negative 0.73. All right, it's going to be somewhere in between 1.5 and 2. Somewhere around there. Last one is going to be our quadrantal angle at pi over 2. So your y value in this case is negative 1, and then your x value is 0. So again, we've got undefined here. We've got an undefined value at pi over 2, which tells me we're going to have a vertical asymptote right at negative pi over 2. Okay, now that we have that, we're going to go ahead and connect our dots here so that we can create the shape of the graph. So we're going to start from 0. All right, so starting from 0, it looks like it's going to kind of curve to the right. It's going to go through these points, and remember that the graphs get closer and closer to the asymptotes, but they're never ever going to cross it. So if I continue this, right, the graph will get super close to it, but it's never going to touch it. Right, that's just the nature of an asymptote. And then same thing in the other direction. Right, I'm going to go through these points, and it's going to get super close to the asymptote, but it's never ever going to touch it. And then that's the shape that we get. That's the shape of tangent. So, however, in the future, I don't want to have to go through evaluating all of those points. So instead, we're just going to focus on 5 points. So you can see on the right, I have created a table with those 5 points. So we're just going to focus on those ones. So we're going to basically start at negative pi over 2, right? And we know that if we plug in negative pi over 2, that gave us an undefined value, right? That's undefined. So we're going to have an asymptote there. Then we're going to focus on negative pi over 4. All right, I'm not going to do the pi over 3s or pi over 6s, because at negative pi over 4, it's really nice, and we get negative 1. Then we're going to focus on 0. 0, we get 0. Then again, at pi over 4, we're going to stick to our positive 1. And then at pi over 2, it's undefined again. So we're just going to focus on these 5 points. These are going to be kind of our reference points for our graph. That way we don't have to graph every single point. And we already know the basic shape of it. So let's go ahead and get a little bit of extra practice on the next slide. Okay, so on this slide, I wanted you guys to get a little bit of extra practice with the tangent. Now that we've kind of seen the shape of tangent, and we know what exactly are going to be the main points. So off to the right, we see the table, and we're going to go ahead and fill in the table. Now you want to memorize this table. That way, every time you graph tangent, you don't need to graph every point. So we're going to start at negative pi over 2. Which we know that ends up as undefined. We know at negative pi over 4, we're going to have negative 1. At 0, we get 0. Pi over 4, we get 1. And then at pi over 2, we again get undefined. So we're going to go ahead and let's go ahead and graph those values, right? The undefined values we know are going to be asymptotes. So at negative pi over 2, and at positive pi over 2, whoops, oh, there it goes, okay, and positive pi over 2, we have our asymptotes. Now we're going to go ahead and plot our points at pi over 4, 0, and negative pi over 4. So at negative pi over 4, we get the value of negative 1. At 0, we get 0. And then at pi over 4, we get 1. So it's really just that easy. Now, it looks like it's a straight line, but we know because of the previous slide that this is going to be a little bit curvier, right? So if I go back to the original slide, see how it kind of has that curve to it? That's the type of shape we're going to have here. So it's going to kind of curve to the right, and it's going to go up. Oh, let me try that again. And remember, it's going to get super close to the asymptote, but it's never going to touch it. And then same thing in the opposite direction. It's going to get super close, but it's never ever going to touch it. Okay, it's not perfect, but that's the basic shape.